Hello everyone, today we are discussing a very important topic, that is friction between pulley and string. So this is not an ideal case where we are taking friction on account in problem solving. So when friction will be present, tension on both the sides of the string will not be same. One side it will be T2 and other side it will be T1. If T2 is greater than T1, then only sliding will occur and friction will oppose it. And we are deriving the relation between T1 and T2 for the limiting case. So let's derive. So suppose we are taking a very small element of d theta, and one side, on the right hand side, we are taking the tension as T plus dt, and on the left side it is T. And if we take the component d theta, its half angle will be d theta by 2. So from interior alternate angles, from the figure you can see that components will be taken as t sin d theta by 2 in vertical direction and t cos d theta by 2, while on the right hand side it will be t plus dt sin d theta by 2 and t plus dt cos d theta by 2. These are some important components. And now we will write the equation. We will write t plus dt minus t is equal to mu into dn. This is the case for limiting condition where sliding is just going to happen. So dt is equal to mu dn. Now how we will find dn? By vertical equilibrium. Dn is equal to t sin d theta by 2 plus t plus dt sin d theta. Here you can see dn is equal to 2t sin d theta by 2 plus dt sin d theta by 2. Here dt sin d theta by 2 is a very small term, so we'll neglect it. Okay, so dn becomes 2t sin d theta by 2. And for small angle we know sin theta is equal to theta, so 2t d theta by 2, so dn becomes t d theta. So dt is equal to mu t d theta, and we'll bring t one side and we'll integrate from t1 to t2, and for theta the limit will be from 0 to theta, where theta is nothing but the contact angle. I have shown in the figure. See, theta is nothing but the contact angle which the string is having on the pulley. Okay, on integrating we will get t2 is equal to t1 into e to the power mu theta. This is an important derivation which you can remember. This is an important derivation. Based on this derivation I have also taken a question. You can see this is very nice question. This is written, shows a cylinder mounted on a horizontal axle. A massless string is wound on it on 2.5 turn and connected to two massless m and 2m. If the system is in limiting equilibrium, find the coefficient of the friction between the string and the pulley. We have to find the coefficient of the friction. Okay, so if one side it is 2m and the other side it is m and the condition is just of sliding, we can take in this case t2 as 2 mg and t1 as mg. Here you can see the solution I have written, and here it is written that it is 2.5 turn, so the contact angle will be 5 pi. So based on the relation we will have 2 is equal to e to the power mu times 5 pi. So taking log both the sides, we will get the value of mu as ln 2 by 5 pi. This was one of the most beautiful question based on it. Without this concept you can't solve this question. So this is very important concept, and when friction is there, so we can remember the relation that t2 is equal to t1 into e to the power mu theta. Other question is there that two masses m1 kilogram and m2 kilogram passes over an anode machine. Find the ratio of masses m1 and m2 so that the string passes over the pulley will start slipping over its surface. The friction coefficient between the string and the pulley is 0.2. So I have drawn the figure, and you can see from figure we can start solving. Assume acceleration as a, and since it is just slipping case, so we can put a as 0 at end. So m1g minus t1 is equal to m1a, considering that m1 is heavier. And second equation is t2 minus m2g is equal to m2a. For slipping condition, we know that t2 is equal to t1 into e to the power mu pi, where pi is the contact angle. Here you can see my contact angle will be pi. So t1 is equal to m1 into g minus a, and t2 is equal to m2 into g plus a. Dividing equation 2 by 1, we get t2 by t1 is equal to m2 by m1 into g plus a divided by g minus a, where a is 0 as it is just going to slip. It is just going to slip. So after this we will get t2 by t1 is equal to m2 by m1, and m2 by m1 is equal to e to the power mu pi. This is the derivation we did, and mu value is given in the question, I think. Yes, it is 0.2. So mu value is 0.2 and contact angle is pi. So m2 by m1 is e to the power 0.2 pi. You can remember this concept, and you will also use this concept in rotation chapter. So I taught this so that you can remember it, and like this I will bring more conceptual videos. I will continue with conceptual videos as well as long videos of concept, but these concepts are important, so I will make separate videos for it. Okay, thank you for joining the session, and just visualize the concept and enjoy physics.